Right, good morning. My name is Mr. Bryn Davis, and I will be doing a revision video on Unit 1.2, Microscopy, and then some exam technique to finish. Okay. Apologies beforehand. Welsh is my first language. If I stumble a little bit over terms, please forgive me. Okay, so for this revision session, okay, I would like you to try the following. If you have a preferred note-taking method, then please continue with that. But if not, I'd like you to try and use this method, okay? So this is the Cornell method, okay? So you take your A4 sheet of paper, you split it into columns, 1/3 and 2/3, and then at the bottom you split the third, and then the bottom there is the summary. Okay, so this bit is the bit that you take during the session. That's going to be the bit that you take now. Okay, so you need to be efficient, paraphrase. Okay, think of like Twitter posts. Okay, short, punchy. Yeah, you know, you don't need connecting words, you don't need all that malarkey. Okay, and then after the lecture, okay, when you go through this, okay, you can add cues or questions that you might have in there that need answering, and at the bottom, okay, you need to summarize. Okay, so summarize it into a couple of sentences. This summary then can form the basis of your flashcards. Okay, so that's the method I'd like you to try and do for this session. Okay, so our session aim today is to recap the subject knowledge for the cells unit 1.2 microscopy. There is a previous video that I have done about the subject knowledge or the content for cells and tissues. Okay, so you can have a look at that again, but today I'd like to concentrate on microscopy and some practicing some exam technique, past papers, and some peer marking. Okay, right, so off we go. This is the syllabus. The syllabus page out of the WJEC syllabus for this unit. Okay, so I've gone through most of these in the previous video. Okay, but what I'd like to draw your attention to is this. Okay, the specified practical work. So you need to learn how to calibrate the light microscope. Okay, and calculations of actual size, magnification, and all the rest of it. Okay, that's something that students can find quite daunting and quite difficult. Okay, but hopefully we will break it down and it will be nice and easy for you. I'd also like to draw your attention to all of the resources that are available out there. Okay, so the WJC website has an awful lot of resources, really good, really useful. The teacher's guide is there as well. That gives you a little bit more detail on the syllabus sentences. That's quite good. They also have blended learning. Okay, so blended learning, if you just Google WJC blended learning, okay, you get a drop-down list of the subject that you want, and there's an awful lot of really good stuff there. Okay. Be careful not to fall into the trap of getting loads and loads and loads of resources, but not actually doing any work yourself. Okay. Fewer, better resources, always better. Okay. Remember, it's your revision that you need to be doing. Okay, good. Right. Okay, so let's get on with some content. Okay, so at ISNA2 will be asked to use images that have been produced using light microscopes and electron microscopes. So we need to do a little bit about the differences between these now. Okay, so both types of microscope use a series of lenses to magnify the image seen by the eye. Okay, they are not under any circumstances to be called telescopes. Nothing annoys a marking person more than a microscope being called a telescope. Okay, so the lens will magnify the image. Okay, so the actual cell under the microscope isn't any bigger, but what you see with your eye is bigger. Okay, so it magnifies, makes that image bigger. two different columns on here, so two different types. So light microscopes, these are the ones that we have in school, okay? Use a beam of light, and you can see how that works here, okay? So you have a beam of light, it goes through a condenser lens, and then it goes through an objective lens, and then it goes through an eyepiece lens, okay? So whatever's sat on the stage here, the specimen, okay, the image is magnified there, and it's magnified there before it gets to your eye. Okay, you can see color images, obviously, because the light is in color wavelengths. You can observe live specimens, which is always quite cool. Okay, if you see brine shrimp or Daphne under the microscope, it's always quite cool. Resolution is quite low power, although some light microscopes you can have a magnification up to about 400, which is quite good for school. They are quite low compared to electron microscopes. Okay. And magnification obviously low, about 400 times. Electron microscopes, beams of electrons, okay, so you wouldn't really want to stick your eye over those. You just see images, you don't stick your eye over the beam of microscopes. Specimens must be dead. If they're not, they soon will be if they're blasted with a stream of electrons. And but basically the pictures are in more detail, okay, higher detail, higher resolution, and at higher magnification. You can have a magnification with electron microscopes up to about 1 million times, so you can see really tiny stuff. Higher magnification, greater resolution. Both microscopes use staining, okay, so this gives more contrast. So contrast means the difference between two different things, okay, so you're more able to see the difference between, say, a red thing and a blue thing than you are between a light blue thing and a dark blue thing, okay. So that is why we stain, in order to have contrast between the two, between parts of the specimen that we're looking at. Magnification and resolution, okay, so these two things can be confused. So magnification is how much bigger the image is than the actual thing. Resolution is basically how clean the lines are, okay. So if you have a specimen that has like fuzzy edges, that is quite low resolution, okay. Think about a pixelated picture. If you have a high resolution, there's a greater number of pixels, okay, which means the line between, where, like my shirt in the background here, okay, so the line between is quite yeah, so a higher resolution means less pixelated, basically, okay. Okay, so this is the thing that students sometimes have a thing about, is calibrating the microscope. Okay, so your microscope in school will have like 3 objective lenses. Okay, so each of the divisions in the eyepiece is going to be worth a different amount depending on how much, depending on what the objective lens is. Okay, so we'll go through this step by step. Okay, so in order to measure the size of a structure, a specimen on a microscope slide, you have to calibrate it. So inside the eyepiece, so the bit that you look down, there is an eyepiece graticule. So the eyepiece graticule is basically the little ruler that's inside there. Okay, so it's a little ruler that's inside the eyepiece lens. It's graduated, so it means there's a ruler on it. Okay, it has 1 to 10 in large divisions, and each of those is divided up into 10 pieces. Okay, so it has a little ruler that has 100 units along it. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 10. Okay, so the eyepiece lens, okay, has a ruler inside it called a graticule. With different magnifications, the divisions on the eyepiece graticule will cover different real lengths of the specimen. Now, remember me saying the image is magnified. Okay, so the objective lens will magnify the image, and then the eyepiece lens will magnify the image as well. Okay, so those different objective lenses will magnify the image different amounts. Okay, so by the time you get to the eyepiece lens, those amounts are worth, they're different actual lengths. Yeah, they're different lengths. You see different lengths because the lens magnifies the image different amounts. Okay. the stage micrometer, okay, so that is the slide with the microscopic ruler on it. Okay, the stage micrometer is used to measure the length of each of these divisions, okay, at different magnifications. And there are two types of stage micrometer available. I sincerely wish there was only one because it would be half as complicated, but there are two. Okay, so this slide has another ruler on it with known lengths. Okay, so we know how big the divisions are on this slide. So we compare those to the ones in the eyepiece unit, the eyepiece graticule here, and that way we can work out how much these values are worth. Okay, so your stage micrometer either is a slide with a 1 millimeter ruler on it. The line is also marked for tenths and hundreds. So there is 100 stage micrometer units, SMUs, on the one on that line. Okay, or your stage micrometer is a slide with 10 millimeters on it, so 1 centimeter, and the line is also marked for tenths and hundreds. Okay, so if you have a 1 millimeter line divided by 100, okay, that means that each stage micrometer unit is worth 0.01 millimeters or 10 microns. Okay, now remember, 1 millimeter equals 1,000 microns. Okay, right. Stage micrometer is a slide with 10 millimeters. Okay, so we're 10 up here, aren't we? Yeah, that we're 10 times longer starting, so we're 10 times longer finishing. Okay, so what you do now is you take your ruler on your slide, your stage micrometer, you stick it under the lens that you want to calibrate, okay, and you compare it to the length of the eyepiece graticule ruler. Okay, so you line up the 0 of the eyepiece graticule and the 0 of the stage micrometer. Make sure they are parallel. Okay, so this here is my stage micrometer, so I've moved the slide so this line is in line with this line. Okay, so we're parallel here. Okay, I'd like to try and pretend that's a straight line. Look at the scales and see where they line up again. Okay, so in our case here, we're lining up that 8 lines up with 20 there, doesn't it? Okay, so this is on the times 40 objective lens. Okay, so here we've got 20 stage micrometer units is 80 eyepiece units. Now remember, it's these tiny units we want to know. Okay, so there are 80 units up to there and 20 units up to there. Okay, so if one stage micrometer unit is 0.01 millimeters, okay, or 10 micrometers, okay, one eyepiece unit is 20 divided by 80, so 0.25 stage micrometer units. Okay, so that means that one of these is worth 0.25 of these. Okay, so one eyepiece unit is the 0.25 we've got there, okay, times the 0.1 that we've got there and the 0.1 that we've got there. Okay, so if I'm timesing that by that, remember you need to multiply by 1,000. Okay, so 0.25 times 0.01 is 0.0025 millimeters. Yeah, and then I multiply that by 1,000 to convert it into microns, which gives me this. So what that is saying is, at the times 40 objective lens, one of these divisions is worth 2.5 microns. Okay. Now, ideally, obviously, you need to learn how that works. Okay, so you need to divide the units of the stage micrometer by the units of the eyepiece, okay, to get the value of 1. Then you need to multiply that by the value of 1 here. Okay, so that will give you the value of one of these divisions. Okay. However, in reality, okay, if you learn that the times 40 objective lens gives you, if you calibrate it once and learn that it's 2.5 microns, that's fine. You just need to remember 2.5 microns. Okay. So equally now, we're going to try with the with the larger stage micrometer now. Okay, so if my stage micrometer now is 10 mil long as opposed to 1 mil long, that means each of these divisions is 1 millimeter. Okay, so exactly the same again. I've got 20 SMUs divided SMUs stage micrometer units divided by 80 EPUs eyepiece units, which gives me the same amount. Okay, that's quite heartening, isn't it? Okay, so we've worked it out the same. Okay, but this time what I'm multiplying it with is different, isn't it? Yeah, so this time every stage micrometer unit is 0.1 millimeter, not 0.01 millimeter. So you multiply them together. So this time I get 0.025, multiply by 1,000 to get it into microns, and this time I've worked out that one eyepiece unit is 25 microns. Okay, and that kind of makes sense, doesn't it? Yeah, if this stage micrometer is 10 times that one, okay, then we're going to be 10 times bigger. Yeah. Okay, so that means that under this with this stage micrometer, okay, measuring, you need to line them up like that. So it's the stage micrometer units divided by the eyepiece units, okay, and then multiply by how much each division is worth on your stage micrometer, and that will get you your value. Okay, right, so let's try and work this out. Okay, so calibration of an eyepiece graticule at times 10 objective lens. Okay, so you follow the pattern for the 4 objective lens to complete the calibration. Okay, so the one on the bottom is the stage micrometer, and the one on top is the eyepiece unit. Okay, now you are probably not going to be able to see the first one, are you? That's going to be a bit rubbish there. But if I tell you we go from, so we've lined it up at 2 there, okay? So I've got that many stage micrometer units, and I've got 10, 20, 30, 40, 50, 60, how many I've got there? 70 something, okay, of those eyepiece units. Okay, so number of eyepiece units, number of stage micrometer units, or stage micrometer divisions rather. Okay, so SMU divided by that equals 0.01. So I need to put that number in there and then multiply it by 1,000 to get me that. Okay, so I'd like you to have a quick squiz at that if you can on a piece of scrap paper. Grab yourself a calculator. And I'd like you to do the same for this one as well. Okay, so try and, so this time we've lined up at 1, that's fine. Okay, where do they line up again? They line up again there, don't they? Okay, that's going to be nice and easy. So 70 of those is going to be worth 60 of those. Okay, so have a go at calculating this one. And this one, you can stop the video and have a go at calculating those, and then in a second I will show you the answers. Okay, so the times 10 objective lens, okay, they've gone for 50 and 70 eyepiece units, okay. So if they've gone for 70 eyepiece units there on the eyepiece graticule and 50 units on the stage micrometer, 50 eyepiece units, 70 on the stage micrometer. 70 divided by 50 is 1.4, multiply by how much one stage micrometer division is. Then you multiply that by 1,000, and that gets one eyepiece unit to 14 microns. Okay, calibration at 40, okay, is 80 to 24. Do you know what I think I've done, guys? I'm very sorry. These pictures are the wrong around, aren't they? Okay, this should be the one at times 10, and this should be the one at times 40, shouldn't it? Okay, so sorry about that. That's a mistake on our part there. Okay, but it doesn't matter if you work them both out. We can still go through the answers, can't we? Okay, so times 40 objective lens. Okay, so it's 80 eyepiece units. Yeah, so that would be the 80 that we had here. Okay, and there would be 24 stage micrometers. 24 divided by 80, 0.3. So that 0.3 multiplied by the value of one stage micrometer unit, 0.03, multiplied by 1,000. So that means that one eyepiece unit on the times 40 is 3. Okay, so sorry those pictures were the wrong way around initially, but that's no matter if you've worked them both out. Okay, so you should be getting something near these. Okay, if these numbers initially that you've taken off the video aren't exact, yeah, that's not the end of the world. Okay, the important thing is that you go through the method of stage micrometer divisions divided by eyepiece units, multiplied by the value of one stage micrometer unit, multiplied by 1,000, and that gives you your microns. Okay, so what we're going to do now is we're going to have a little practice. Okay, so this picture is slightly better. Okay, so what I would like you to do now is I would like you to stop the video, and I would like you to have a go at calibrating the calibrating question 1A. Okay, so have a go at 1A for me, please. Okay, so remember, eyepiece graticule, stage micrometer, how many of these per some of these? So they are nicely lined up there, I think. Okay, need to find out. So they're lined up there quite nicely. Okay, obviously the longer your the bigger the numbers here, the less room for error you've got. Okay, so if you just doing 5 stage micrometers for eyepiece graticules is not ideal. Okay, you need to try and do bigger numbers. Okay, so I'm going to shut up now. I'd like you to try and work that out if you can, please. Okay, so you can stop the video if you haven't finished working out, that's fine. All right, but this second part, part B, okay, is how you are going to use that value you've calculated to work out the actual length of something. Okay, so using the same microscope, student examined a slide cross-section developing plant ovary. At the point indicated by the line, the developing ovary was 31 EPUs, eyepiece units long. Use your answer to calculate the actual length. So here you have calculated the value of one of those divisions, haven't you? Okay, and this line here is 31 of those. Okay, so you need to multiply the number you have there. So you need to multiply, that's supposed to be a question mark. If you multiply your question mark by 31, okay, that should be your answer. Okay, remember, it does say give your answer in millimeters to 2 significant figures. So don't get tripped up by, you've worked out in microns here, haven't you? Yeah, so you need, if you've worked out in microns, you need to convert that back. So you need to divide by 1,000. Okay, so yeah, just be aware, if you're doing calculations, it's better to have all of the numbers in the same unit. Yeah, it's just easier if they're all in microns or all in millimeters. Okay, and then you can either convert at the end or convert at the start, but it's easier just to have them all the same. Okay, so 31, which is the 31 eyepiece unit, multiplied by the value of 1 eyepiece unit, and that will give you your answer. Okay, so I'd like you to do that now, and then you can stop the video and I will publish the answers just now. Okay, so they've gone really long here. So 64 eyepiece units is 100 stage micrometer units. Okay, so they've used the entire stage micrometer, which has taken us all the way to 64, not 65. Okay, so then stage micrometer divided by eyepiece, 1.56. Okay, one stage micrometer is worth 0.01. Multiply times by 1,000, so that's converted me to that. Okay, so that is the value of 1 eyepiece unit. So we worked out on the second part of the question, there was 31 eyepiece units, so that multiplied by that gives us that 483.6 microns. Remember, they wanted it in millimeters, so you need to divide by 1,000 in order to get that. Okay, and then to 2 significant figures, 0.44. Okay, now remember, when you're doing these calculations, okay, you need to be aware of the type of numbers you're going to get. Okay, so that was talking about a plant ovary. Okay, so if a plant ovary is 4 meters long, that doesn't smell right, does it? Yeah, that doesn't make any sense. Equally, if a plant ovary is 0.00002 microns long, that as well isn't making sense. Okay, so you need to use, so do your calculations like you normally would, and then just use a pinch of common sense at the end just to make sure that the answer is in the right ballpark. Okay, if it's not in the right ballpark, go back and check. If you've checked and done your methods right, then that's absolutely fine, leave it. Okay, if you've gone back and checked and it's not, then correct your answer. Okay, good job. Right then, so now it starts to get a little bit more complicated. Okay, so you can, you've calibrated your microscope, fine. Okay, so you can work out the actual size. Okay, so you can work out the actual size, that's fine. Okay, now this is to do with how much bigger the drawing that you've done or the drawing that you get in your exam paper is than the real thing. Okay, so this has come from the calibration. Okay, and these are all to do with the drawing that you've done. Okay, so this is a formula triangle. Okay, quite an easy thing to drive if you can remember. Okay, so I at the top, I am, okay, is one to remember. So I at the top, am at the bottom. So I stands for the image size. So that's the size of the picture. All right. M is for magnification. So M is how many times bigger the picture is than the real thing. Okay. So you can work out the actual size by dividing the image size with the magnification. You can work out the magnification by dividing the image size over the actual size. And you can work out the image size by multiplying the actual size by the magnification. Or you can also work out the image size by measuring it with a ruler. Okay, so those are the three, or the two really. The image size doesn't really count, but the image size, yeah, like I said, doesn't really count. But those are the two formulae that you need. Okay, so the actual size is image divided by magnification. Magnification is image divided by actual. All right, so these can be asked. So you could be asked to measure a image on the exam paper and calculate the actual size, calculate the magnification. Okay. Drawings that you do, this skill is becoming slightly redundant these days as we all have phones in our pockets, but it needs to be a scientific diagram. Okay, drawing. Okay, so it needs to be sharp pencil, no shading, no feathering. I would say no artistic skill at all, but you do need a good eye. You need a good eye for proportions, stuff like that. Okay, so those are the things that you need to be aware of when doing a drawing. Okay, and then, like I say, those two formulae are what you need to know. Okay, so calculation of actual size. Okay, so this image has a magnification. So we've got M is of 10,000 times, so it's 10,000 times larger than the real thing. Find the actual size in micrometers. You mark where you're going to measure. So, okay, so we're going to measure between there and there. Be careful, some students will stick their ruler on and measure from there to there. Okay, and some will measure from here to here. Okay, you need to measure from that line to that line. Okay, that is the length of the line. Okay, that's why they've got those horizontal pieces or those vertical pieces on the line. Okay, so measure between there to there. Okay, so mark on the image, measure the line in millimeters. Okay, you convert that to microns, you multiply by 1,000, so that, okay, is the size of the image. That is I. Okay, and remember, I am. Okay, so I want to work out the actual size. So if I cover that, it's image divided by magnification. So I've worked out the image size, and the magnification that I've got out of the question is 10,000. So the actual size of this nucleus is 11 microns long. Okay. Equally, if this question asked us to work out the magnification, cover magnification, that's image size divided by actual. Okay. Calculate magnification, that's exactly what we're going to do now. So when you've drawn you need to, okay, so you know that the size of the actual cell is between A and B is 50 microns. Okay, so yet again, I am. Okay, so we can measure the image size, that's fine. That line and that line, I'd like you to pretend they're straight. So we've got the actual size, which is that. Okay, measure the distance between A and B in millimeters. Okay, so we've measured it, it's 25 millimeters. Multiply by 1,000, so that is equal to that. The actual I've got here, that's the actual. So I over A equals M. Okay, so that is M. No units here, remember, yeah? Magnification, it's just how many times bigger it is than the real thing. Okay? Good job. Right then. So using scale bars. So sometimes scale bar is given, line is drawn, so this will be on an exam question. Okay? By measuring the length of the scale bar, it represents, you can calculate the magnification and the actual size. Okay, so students sometimes have fun with this because they just whack it into an I am formula without actually clocking what it means. Okay, so the image of electron micrograph in animal cell, its printed copy scale bar was 15 millimeters long and represented a value of 2 microns. Okay, so the scale bar is 15 mil. So I've converted that to microns. Okay, so if the image divided by the value gives us the magnification. Okay, so that's the real size of the image. Okay, that is actually how long it is. Okay, so I over A again gives us the magnification. Okay, actual size using a scale bar. So you mark on the drawing where you're going to measure, divide the length of the line you've drawn by the length of the scale bar. Okay, so you have to put something on. So you're going to put that one there. Like that. Okay, so you measure the length of yours. You measure the length of the scale bar. You divide them. Okay, so that means that in this case, okay, the line that you've drawn is 7.7 times longer than the scale bar. Okay, then you multiply this by the actual length. Okay, so you've basically what you've done there is worked out the magnification, multiply by that, and that gives you the actual length. Okay, so that is how you drive a scale bar. Okay, it's slightly more complicated than just the I am formula. Okay. Right, okay, so what I would like you to do now is I would like you to have stop the video and have a go at these questions, please. Okay, you can refer back to any points or refer back to the notes that you've been making. Okay, but I'd like you to try and answer those questions, and I'm going to publish the answers just now. Okay, here's the second part of the question. So in a second, I will publish the answers. Okay, so these are the answers for the previous question that you've done there. Okay, so make sure that you have understood and you've gone through the answers and clocked any problems that have arisen. Okay, good job. Another one. Okay, so first part of the question again. You can work out your answers, and then I'll publish the answers in a second. Remember, if you're not overly confident, it is hugely important to show you're working out. Okay, there are always marks for working out. Okay, don't be a lazy daisy and just stick a number in here. Okay, you need to be super confident to do that. Okay, make sure that you've got your workings out there, and that way, if it's not 100%, you'll get something. Okay. Okay, here are the answers to that question. And another one. And there are the answers for that one. Okay, so the previous video and this one have gone through all of 1.2. Okay, so you need to make sure that your notes are up to date for that. Okay, application to exam questions, basically doing all the exam questions, is really, really important. Okay. So the following slides, they've got a mixture of past paper questions for you to try and some peer marking exercise. Okay, remember 50% of your revision needs to be notes and getting the knowledge in your head, and 50% needs to be practicing past paper questions. Okay, so first one, some of you may recognize this one, so stop the video and you can have a bash at that, and I will publish the answers in a second for you. Okay, so answers coming up now. Okay, so you can stop the video there and make sure that you have got that right. Okay. Part C there, actually a different unit. Yeah, different unit. The biochemistry unit there. Okay. Okay, and there's the answer to D for you. Okay, next question. So here are, so you're welcome to stop the video and then you can have a go at those on paper, and then I will publish the answers just in a second. Okay, so here are the answers. If you would like to correct the correct your attempt, that'd be brilliant. Okay, same deal again now. If you'd like to pause the video here and have a go at answering that question. And here are your answers to the previous question. Okay, one more. And there are the answers for you. Okay. Last one, I'm thinking, before we try some peer marking. Okay, and the answers are coming up just now. Okay, so again, if you'd like to pause the video just there, and you can use that to mark your answers. Okay, so what we're going to do now is going to do a bit of peer marking. Okay, so I'd like you to have a look at this question and have a look at the marks that Johnny, or have a look at the answers that Johnny's written. Okay, if you'd like to scroll back in the video, you can find the mark scheme for this. Okay, so I'd like you to try and tell me how many marks you think Johnny has got for that question, and then I will publish the actual marks he got. Okay, so this one, okay, mislabeled his organelles. Okay, Johnny's maths is obviously very good. Okay, he's got his he's remembered his formula triangle there, worked that out, converted to that, divided by, brilliant, good. This, although a good answer, isn't detailed enough. Okay, there's not enough detail in there in order to warrant any marks. And Spirogyra is eukaryotic and Nostoc is prokaryotic. One, Spirogyra has membrane-bound organelles. He's missed out that Nostoc does not. Okay, you need to make direct comparisons. This is this, that is that. Okay, don't just list qualities. Okay, so Johnny got 3 there. Right, next one. Yet again, you can scroll back in the video and find the mark scheme for this. And I'd like you to tell me how many marks you think Johnny got for that. And here are his answers. Okay, so again, correctly labeled. Okay, this one, this means there's a word missing. Okay, so there's a word or important term missing. Okay, so again, oh, pardon me, there's a bell going off in the background. It'll finish just now. There we go. So again, missing a term just there. Okay, so I'd like you to go to that and check how many marks you think he'd got and compare with Johnny's actual marking there. And a last one, I think, here. Okay, so this is the same question that you've had to answer. Okay, so you've answered it. You can scroll back through to find the mark scheme. Okay, and just about to publish the marks that he got now. Oh, pardon me, I've skipped through that one as well. Okay, so there are some more answers that Johnny has provided. Okay, so you're welcome to stop the video, check his marking. All right. And last of all, okay, so yet again, Johnny's obviously a very good mathematician, or he's watched this video before answering his questions. So there's yeah, two marks there, good, yeah, and shown his working out there, very good. Okay. Similar job, yeah, similar function. What is that function? Okay, you need to be more specific there. Now, if you look at the mark scheme, it says that the bladder cells, or I think it says the tissue will be able to stretch, yeah, which is slightly different to the bladder will be able to grow. Okay, so growth means something different to stretch, doesn't it? Okay, so again, you need to be very specific and have that level of accuracy in order to get the mark. Okay. Right, so just a few techniques there for you. Okay, remember there are many different ways of revising, and if you have one that works well, stick to that by all means. Okay, remember you need recall information. You need that information at the tips of your fingers, and you need to apply it to old questions in order to succeed. Okay, so remember to work hard, and all the very best in your exams. Goodbye.